Alright, in 12.6 we are going to divide some polynomials. We've already talked about multiplying them and then adding and subtracting them. So we're going to start off with the easy ones, dividing a polynomial, so more than one term, by a monomial, which is one term. So what this problem really says here is that I have 8p cubed minus 4p squared plus 12p, and all of it is being divided by negative 4p squared. Okay, so I know some people are really tempted to just cross these guys off since they're exactly the same thing, but we can't, because this 8p cubed also needs to be divided by this, and so does this 12p. So if we erase all of this, we can rewrite this problem as 8p cubed divided by negative 4p squared minus 4p squared divided by negative 4p squared plus 12p divided by negative 4p squared. And now this is turned into problems that we know how to divide. So take a look at just your numbers and then take a look at your variables. This first one will simplify into negative 2p. Two negatives right here make a positive, and then everything crosses off, so we end up with 1. And then this one here, 1 positive, 1 negative, so we again end up with the negative. 12 divided by 4 gives me 3. And then we have more p's in the bottom than we do in the top, so it needs to be 3 divided by p. So this is it. We can't combine anything else. We divided everything that we could, so we're done. Why don't you guys pause the video and try the next one on your own. Alright, so now we're going to get into ones that are a little harder. So we've already done some of this stuff before in the multiplication and the addition stuff, but the first thing we want to look for is seeing if we can factor the numerator and denominator. If we can, like this problem over here, makes it way easier to be able to cross stuff off and to divide. So we divide out any common factors. So both of these had an r plus 2, so we can cross those off. And then we see we're left with just that r plus 1 that was on top. We technically do the same thing with numbers, as you can see in this column, but we don't tend to write it out that way. So let's do some of this stuff. It should just be kind of review since we've already done stuff like this. So let's look at 2a. The very top thing is a trinomial. So let's see if we can factor this. I need two numbers that add to make 7 and multiply to make 10. So we got 2 and 5. So that means on the top I have x plus 2 times x plus 5. And it's all divided by, oh, these should be k's. I like x's. So it's all divided by x plus 2. So we can see that they have some stuff in common, and because they do, we can cross them off. So our answer is x plus 5. And I know you guys are thinking, well, we already did this stuff, but we technically did this stuff when we were multiplying. We divided them out. Multiplication and division are best friends. Try 2b and 2c on your own. Okay. So you guys should have gotten b minus 7 for the first one, and then the second one, s plus 6. Keep in mind that it doesn't matter on the top here. You could have crossed off this s plus 6 or this one. Doesn't really matter as long as only one of them cross off. Alright, so now getting to the hard stuff. We can only cross stuff off like we did here if they have something in common and if they can factor. But just because they don't have something in common or can't factor doesn't mean that we can't divide them. Just like numbers, 5 divided by 6, they have nothing in common. We can't cross anything off, but I can divide that and end up with an answer. It's a messy answer, it's a decimal, but I can still end up with an answer. So that's what we're going to be doing today, is figuring out messy answers for polynomials. So I'm going to do a couple that we could factor with so that we know we're getting the correct answer. And then we're going to do some that have remainders that are messy that we couldn't factor. So if you're given a problem like this, first thing you want to do is set it up like a long division problem. And we can treat this just like a long division problem that we did back in the day. If you do 8 divided by 128, you see how many times can 8 fit into 1? Well, it can't, so then you move on. How many times can 8 fit into 12? It fits in once. And then if you remember, you took 1 times 8 and wrote it right here. And then we subtracted. And what we're doing here is finding out what's left over. Yes, 8 goes into 12 once, but there's leftovers. And there's 4 left over. And then we brought the 8 down. And then asked the question again. How many times can 8 now go into 48? And we know it goes in 6 times. So then you multiply again. 8 times 6 gives you 48. And when you subtract those, you have 0 remainders. So that means 8 goes into 128 exactly 16 times. So we're going to do that exact same thing with polynomials. It's going to be tricky and it's a lot of steps, but once you get the hang of it, you should be able to do any problem I give you. So what we're going to do is just look at this front term right here, x. And we ask ourselves, how many times can x go into 2x? Or sorry, x squared. So we're going to ask ourselves, how many times can x go into x squared? So it goes in 1x time. And I'm keeping the x here because it's in the x column. Just like back here with my numbers, this 1 was in the tens column and the 6 was in the ones column. So then we're going to do the same thing that we did for the numbers. We're going to take this and multiply it by everything here. So you do x times x, which is x squared. And then you do x times 2, which is 2x. Now our next step is to see what's left over. Just like we did here, we have to change the sign and subtract to find out what's left. So I want to subtract x squared and subtract 2x. So if I subtract x squared minus x squared, I get nothing here. That crosses off, which is good. And then 3x minus 2x means I'm left with 1x. And then again, just like our numbers up here, we want to bring down the next term. So we're going to bring down a positive 2. And then we go through and ask ourselves the same questions again. How many times can x go into x? And it goes in 1 time. And then we're going to multiply 1 times x, which is 1x. And then 1 times 2, which is 2. And then to find out what's left over, we need to subtract. So we subtract both terms here and we see that we get 0. Just like the numbers, that means it goes in exactly x plus 1 times. And if we would have factored this thing out, we would have ended up with x plus 2 times x plus 1. And then since we divided it by x plus 2, this stuff still crosses off. And we're left with x plus 1. Obviously, factoring is way easier. And for a problem like this, factoring would be the way to go. But, again, there's going to be some that you can't factor, or some that you factor and they don't have anything in common, so we can't cross them off. So we were just practicing on a problem that we know we could do and check our answer. So let's try another one together. First thing you gotta do is rewrite it. So you always put what you're dividing by on the outside. And then on the inside, we have a squared minus 8a plus 12. So then we got to go through step by step. How many times can a fit into a squared? Well, it goes in 1a time, or you could just write an a there. And then we have to multiply. So a times a gives me a squared. A times negative 6 gives me negative 6a. And now remember, we want to see what's left over. So we need to subtract both of these things. And if you subtract a negative, we know you're really adding. So our a squareds cancel out. They always should. And then when we get this, we have negative 2a's, and then we have to bring down the next term, bring down the 12. So then you ask yourself, how many times can a go into negative 2a? And it goes in negative 2 times. And then we multiply. Negative 2 times a gives me negative 2a. Negative 2 times negative 6 gives me positive 12. And then to see what's left over, we need to subtract. So if you're subtracting negative 2a, you're really adding it. We got to subtract here. And we see that everything crosses off. We have a remainder of 0. So that means if I divide a squared minus 8a plus 12 by a minus 6, I'm left with a minus 2. Same thing if we were factoring. If we factored this guy, we would end up on the top with a minus 6 times a minus 2, all divided by a minus 6, and we can see that this stuff cancels out. Again, way easier to do with factoring, but some of them aren't going to be able to factor.